Yeah, back to this question on substitution. So you can see that for this question actually, possible to integrate in terms of theta. But they have this requirement. They want to test you on the substitution method. So you are supposed to make use of the substitution method to integrate in terms of t, not theta. Okay? So you are supposed to show that this is actually equivalent to this based on this substitution. So what we are going to do is we have to change all the variables theta to the equivalence t. Okay, so what we are going to do is we will have to replace this d theta. So some of you actually show me this. Okay, I mean in your working lah, you didn't tell me verbally, but you show me that okay, this theta, right? Actually, how do I replace it? Is that I make theta the subject. So you have t goes to tangent theta. So when you differentiate t with respect to theta, you get secant square, right? Okay, then you do the sort of like reciprocal, okay, because secant is 1 over cosine. Okay, so when you have the like sort of reciprocal, you get this. So some of you actually presented it like this. D theta is equivalent to cosine square theta dt. Okay, I guess that's fine, okay? So in other words, what you are doing is this theta, right, you actually cross multiply over to the other side. Technically speaking, this is a function, it is not a fraction, okay? So not so correct, but if it does help you to see the replacement over here, right? Okay, I think it's okay if you do it as a side working. Okay, Ken? So this d theta, you actually replace it with cosine square theta d theta. So that actually you will get the integration with respect to theta instead of t instead of theta. Okay? Then, when you have substitution that involves trigo ratio, it will be necessary for you to know that the sine, cosine of the angle can be found. So if you have tangent theta equals to t, right, it is telling you that if the right angle triangle has theta here, okay, that means the opposite is t, and then the adjacent has a value of 1 or 1 unit. Okay, so then with that, hypotenuse can be found with 1 plus t squared. Okay, Pythagoras theorem. Yeah, so you can see that with this triangle form, you are able to write out any of the three trigo ratios, sine, cosine, tangent. So in this case, because when you are converting from d theta to dt, you need cosine, so this is your cosine, right? Okay? Yeah, so we can see that cosine square is actually 1 over t square plus 1. So you must stay focused. What do you need? I need to change every theta to the equivalence t. Okay? So now you can see that everything is ready. We are ready to replace this d theta with this. Okay? We are now ready to replace cosine square with our t. So we can put them in now. Then you say, oh my goodness, what is this? How do you actually simplify this expression here? Okay, so what I have shared with you in the previous example is, usually I will get students to do numerator times numerator over denominator times denominator. So this is what I will encourage students to do. Reason being, there are terms that you can cancel out. So you can see that for this, right, the denominator of the first fraction is this. Okay, this is the denominator. Then the denominator of the second fraction is this. If you use denominator times denominator, right, that means this term is multiplied to here. You will see that actually the t squared plus 1 got cancelled out. You just get a 2 only. Okay? And your t squared plus 1, you multiply by 1. Okay? So you won't get into this kind of very complicated expression, which I suspect some of you did try to do. That's why I leave the answers here, so that if you are still prefer to do it this way, you can do it correctly. Okay, but what I will do is I will use my method of numerator times numerator. You get 1 times 1 over denominator times denominator. You will see that you should get 2 from the first expansion, and then minus t squared plus 1. You get the second expansion. Okay, and yeah, correct. Yeah, minus of this whole thing. Yeah. So then you can see that the simplification is actually quite straightforward already. 1 minus t squared, which is what you essentially need to show. Okay, so you can see that there are 2 types of simplification. Okay, one is you do the prim and proper way, the usual way, you simplify the denominator and you perform the division. The second way is just numerator times numerator, denominator times denominator. Okay, so I leave it up to you which way you want to do. Don't try to squeeze this all into one line lah. If it is really very big, a big fraction, then just spill it over 2 lines. Okay, so and you can see that with this expression, it is so much easier to integrate, because this is actually the same exact form that you can find in MF27. But I think Ritesh shared with me before that he doesn't prefer that way. He still prefer to do a partial fraction. That's fine as well. Okay, it's really up to you whether do you want to do it by your MF27. Okay, wait, let me just show you the thing about where you get it from MF27. Okay, yeah. So you have your 1 squared minus t squared. So if you are going to use this, and some more this is t squared, so don't even have to account for the coefficient. Yeah, this is the answer. Then change what? No. I need to change something. This one cannot be bracket, must be modulus. Okay, because the range of the value of t is not defined. Okay, so we will have to perform it. But okay, wait, I think I jumped too far ahead. I forgot to go back to the question. So hence, so that means we are supposed to make use of this to show that this integration, okay, now that we have the limits, the answer is as follow. Okay, so we will have to change the limits. So you need to find the corresponding values of the upper and lower limit. So this is the exact value that we have to work with. Yeah. So you can see that for this question, they just leave it from the MF27. So again, how do you simplify this? So what we do is we multiply root 3 to the whole numerator and multiply by root 3 to the whole denominator. So actually, this can be an answer on its own already. Okay, this one. But why is it that do we need to multiply by this? So we have a form that we need to show, right? Yeah. So the form is we need to show that this expression, the value is half ln 2 plus root 3. So definitely you see this answer is not. Then how do you make it into 2 plus root 3? So the reason is like similar to what you have learned in your secondary school. I think in secondary school when you learn A math, right, they actually always chase after you. Hey, you need to rationalize the third form. You need to rationalize. You cannot have square root at the denominator, correct? In your A math. Yeah, so this is, I mean for leaving square root in the denominator for A levels is actually fine. But for this particular question, they want you to leave it in this form because they say that you must show. So that's the reason why we are rationalizing it. So this term is actually what we do to rationalize the fraction. Okay, so this is for rationalizing. To get to the show. Yeah, the show part. Okay? Yeah, so with that, then you can see that the answer is as follows.